So question number 5, a boy looks at the image of a clock in a plane mirror. Figure 5.1 shows the mirror, the clock, and the position of one of the boy's eye. Then the first part of part A. On figure 5.1, draw a ray of light from the clock reflected to the boy's eye. So this is basically the image formation of a plane mirror. So there are specific steps, there are certain number of steps that you need to follow, that you need to execute to draw the ray diagram or to draw the image formation by a plane mirror. You draw the object's image on the other side of the mirror at the same distance with respect to the object. So the image is drawn equidistant from the mirror with respect to the object. So this is your image. Okay, we can say this is the image. We draw it in exactly the same line, but we ensure that these two distances, this one and this one, these two distances should be equal. And here we assume that these two distances are equal. So then we have the next step, and that step is from the image, draw a ray towards the eye. So once you have drawn the image, then you need to draw a ray. You need to extend a ray from the image towards the eye. So that will look something like this. And one of the property of the image is, of this ray, is that the part of the ray that is behind the mirror is represented by a dotted line. On this side we have the object, and on this side we have the image. And in the next step, the final step is you draw a ray from the point of intersection. This is POI, the point of intersection. You draw a ray from the object towards the point of intersection. So that would look something like this. And in the final step, you draw the arrows. Arrows are drawn in such a way that they are away from the object and towards the eye. So that will look something like this. So the first part, we can put a check mark over here. Then we have the next part. On figure 5.1, mark with the letter X the position of the image of the clock. Okay, so we already located the position of the image. All we gotta do is to mark it with the letter X. So this was the image we represented by I. I'm going to cut it off, and we are going to mark it with the letter X. This is the position of the image of the clock. Then we have the next thing. State whether the image formed by the mirror is virtual or real. And then in the next step, they ask you explain your answer. So you have to first state if the image is real or virtual, and then you have to explain your answer as well. So is this image, matter of fact, any image formed by the plane mirror, is it real or virtual? Okay, so the thing is, the image that is formed by the plane mirror, it has some properties. One of the properties is the image is of the same size, and that image cannot be projected on the screen. This is the most important thing. The image that you see of yourself in the mirror, you cannot project that image anywhere on the other screen, except for like if you have more mirrors, but that is another thing. That is just a reflection. So this image is virtual, and the explanation is, and see, the other thing is, in any diagram, if you see the dotted lines, these kind of dotted lines, that would imply that the image is virtual. So you see the dotted lines, that is straight away an indication that the image is virtual. Since the rays of light were not actually intersecting, you extended them backward. Now they appear to be intersecting. And with this we can write. Move on to the next one. Figure 5.2 shows the image of the clock seen by the boy. The boy now looks directly at the clock. On figure 5.3, draw what the boy sees. So this is the image of the clock. This is not what the actual clock looks like. This is the image of the clock. And once the boy looks at the clock directly, what would the clock look like? So you see, the easiest thing is, one of the property of the image formed by the plane mirror is that the image is laterally inverted. I repeat, one of the property of the image formed by the plane mirror is image is laterally inverted. I mean, if you open up your smartphone, you go to the camera, in the editing options there would be one of the option where you can flip the image horizontally. So if the image is like this and you flip it horizontally, it would now look like this. So this is called laterally inverted. So if I draw the laterally inverted image of this thing, it will look something like this. So in the image, it appears, if we ignore the numbers, okay, if we ignore the numbers, it would appear that it is like 3 o'clock, but in reality, it would be 12 o'clock. Sorry, 9 o'clock, not 12 o'clock. It would be 9 o'clock. Let's move on to the next one. So here we have the next one, part B. The clock is illuminated by a source of monochromatic green light. What is the meaning of monochromatic? I mean, the answer is in the question itself, monochromatic green light. So that is a single color. Monochromatic refers to a single color, and each color has a specific frequency. So green color has a certain frequency, and if you're referring to only green color, means we are referring to a certain frequency and a specific frequency. So what we can write is a light of a single frequency or a single wavelength would be called monochromatic light. In IGCSE, that is part of the syllabus. Here in O levels, we don't actually need it, but still, just to be on the safe side, we can do it. Then we have the next question. The green light has a wavelength of 5.60 to 10 to the power minus 7 meters. Okay, so we can represent it with the wavelength, represent the wavelength with the symbol lambda. Calculate the frequency of the green light. So F needs to be calculated, and the formula that we have that relate these three things is V equals to F times lambda. Speed equals to the product of frequency and wavelength. Now the thing is, you do have the value of wavelength. Frequency needs to be calculated, but then what about the speed? We don't have the value of speed, so what should be done? This is a fact that you need to memorize, that the speed of the waves of all the electromagnetic waves, be it light waves or X-rays, gamma rays, speed of all the electromagnetic waves in meter per second equals to 3 into 10 to the power 8. So this is the value of speed. You use it in the equation, you have to memorize it as it is. So instead of V, I'm going to write 3 into 10 to the power 8. Then instead of frequency, you can write F as it is, because this needs to be calculated. And then you can write the wavelength, which is 5.6 into 10 to the power negative 7. From there you can find the value of F. Somebody hit it on the calculator and let me know the answer. into 10 raised power 14. Okay. With the unit of hertz.